Okay. All right. Oh, we've started. All right. I was going to give kind of a maybe a 30 or oh wait, what the hell did I hit here? Dang. All right. Anyway, I was going to give about a 30-minute review or something like that, but I don't think that's necessary. I've been looking at the well. First of all, I'm kind of like, hey, you got to do some work yourself. And when I check the homework assignments and I see that almost 60 out of 150 students haven't even tried homework one, and probably 120 out of 150 haven't started homework number three yet, haven't even started it. Um, I'm like, hey, figure it out, okay? This is physics, and I've been saying for 3 weeks in every class period, you've got to practice. You have to practice, practice, practice. And you've got to do the homework, and you've got to look at the examples in the book and work them out. And they also give you check for understandings, which are great too, that are interactive. Let me show you what I mean, okay? And then you all can take it from there. Now, we'll cover, so there's vector stuff, all right, on how to compute vectors, which we did in class. We spent an entire class period computing, vectors and angles and stuff like that. And there's, and then of course we've got kinematics in one direction, either going this way or going this way. And then in chapter 3, we combine the two. But let me show you how to, you've got a little bit of time. It's 3:15 in the afternoon, okay? And I will show you here what so you got between now, you've got about 20 hours to figure this stuff out, but I guarantee you should go to bed about 10 o'clock anyway to get up to take the exam. So without further ado, let me show you. Now here's the thing on displacement. Well, let's go to the free falling bodies part. All right, because that seems to kind of mess people up. Okay, so here's the book on free falling bodies. This all looks nice and good. Here's an example 9. All right, a stone is dropped from rest at the top of a tall building. After 3 seconds of free fall, what is the displacement of the stone? That's a great question. How far did it fall? And then maybe what's its final velocity after 3 seconds? Okay, and I think you can even get animated figures here or something. Yeah.
We will look at another way to think about a freely falling object. We will consider a stone falling from the top of a building. The initial velocity is 0 meters per second, and the velocity at the end of the first second is 9.80 meters per second, where downward has been chosen to be the negative direction. Since the acceleration is constant, the average velocity is midway between the initial and final velocities. So the average velocity during the first second is negative 4.90 meters per second. For constant acceleration, the distance traveled is the average velocity times the time.
There you go. There you go. I mean, they've got all these things in there that you can be using that I feel like you need to go in there and look. All right. It's been 3 weeks. You need to go in there and look and just work through it one step at a time. All right. And you should be fine. Okay. And anyway, they go ahead and work it out. Reasoning, the upward direction is chosen as a positive direction, 3 unknowns. Okay, here's the acceleration, the velocity we don't know, and then they pick this equation, which I would too, because the initial velocity is 0, 1/2 at squared, 0 times 3 plus negative 1/2 at, so it fell in those 3 seconds, negative 44 meters. All right. The final velocity at the end of that time, you got v equals v naught times at. I mean, it just walks you through your basic formulas that you need to do it, and they also provide explanations. And that's what I've been telling you all semester. Okay, so far the first 3 weeks. Do the example. Here's example 12. What is the total time the coin is in the air before it returns to its starting point? There you go. We did a problem like this in class. For it to get halfway up took this long, and for the total trip it take this long. Or you could have used v1 minus, if you knew that it went up at positive 5, then this would be negative 5. So you get negative 5 minus, you take 10 divided by 9.8, and you see you get the 1.02 seconds. All kinds of ways to do it. Okay? So let's go to chapter 3 real quick. And if I can, I have to go all the way back in to get to chapter. Okay, fine. All right, I'll go back in get to chapter 3 here real quick. Read, study, practice. There it is. Boom. Click on that. You probably don't have time. Some of you that really know this stuff might enjoy watching some of the videos and get some just that little bit of extra insight. Okay, kinematics in two dimensions. All right, here it talks about, if it's accelerating in the x direction and taking off in the y direction and all that kind of stuff. We're not doing that type of problem. What did I tell you we're doing? We're just doing a regular problem of projectile motion type thing, okay? But you need to learn the displacement and the velocity. So we do a problem like this. You might have a problem like this. Here's example 3, a falling care package. You can go through and work it out again with them. Example 4 shows the magnitude of the final vector when it hits. If you work through all these examples and go through their thing, you should be fine. And then we did this problem. Here's example 6. Here's an example 7. And if you go through these and you understand them, you should be fine. Okay? Example 6, 7, and 8. There it is. All right? You don't need a review from me. And while you're doing this, the concepts will be done over and over and over again for you, okay? Because I've looked at the exam, I've gone, hey, it is fastballs down the middle. You should be okay. All right? And then when I look at the homework scores, I'm like, hey, you got to do some of the work yourself, too. All right? You got to meet me halfway here. All right? I'm not going to spoon feed you. We're not, in high school anymore. Okay, out here.